Good morning, students. New chapter, chapter 4, motion in a plane. Yes, we have completed one lecture. Now it is second lecture. But you have to remember what is vector. Vector quantities means quantities dealing with magnitude as well as direction. So direction is important. How to represent any vector? Yes, with the help of an arrow. With the help of an arrow. Arrow, its length, it gives magnitude of that given quantity. Okay, and head is in direction of effect of that vector. Okay, so you know how to represent any vector. Okay, now here, now we will start some processes: plus, minus, multiplication and division. First of all, the easiest method, okay, and easiest process for vectors is multiplication of vectors by real numbers. Multiplication of vectors by real numbers. By real numbers, or you can say with scalar. With scalar. Multiplication of vectors with scalar. Multiplication of vectors with scalar. Okay, so whenever one vector quantity is multiplied with scalar, what happens? See, here we will consider two cases. Okay, because real numbers, they may be positive or negative. So first of all, we will consider one part. We will multiply vector with positive number, and then we will multiply with negative number. See what happens. Multiplying a vector A, vector is named A. Okay, multiplying a vector A with a positive number lambda. Multiply a vector A with a positive number lambda gives a vector whose magnitude is changed by factor lambda, but the direction is the same as that of A. Now what is meaning of this? Okay, we will take one example. See, for example, we have one vector A and is multiplied by 2 and is multiplied by 2. Then what is new vector? The new vector, resultant vector is 2A. Resultant vector is 2A. Okay, is in same direction as A and has a magnitude twice of A. It means when you see its figure, it is easily understood. Okay, see, it is one vector A. It is one vector A. Okay, if this vector A is multiplied by 2, that is positive number. You have to remember, whenever you multiply any vector with positive number, direction of new vector remains same. Direction of new vector remains same. Just its magnitude is changed. Okay, its magnitude is changed. See, initially it is vector A, it is its length, means its magnitude. Now if we multiply this vector by 2, then yes, magnitude of this vector becomes twice. Magnitude of this vector becomes twice, means length of arrow becomes twice. Clear about this? Okay, so simple. Whenever you multiply a vector by positive number, direction remains same and magnitude depends on number that you have multiplied. Clear? See, lambda is one symbol, lambda is one number that we have to assume. Okay, it may be 2, 3, 4, 5, 6, 7, 8, etc., etc., etc. Any number, 1.5, 2.3, any number. Okay, so it is first case. Multiplying a vector A with a positive number lambda gives a vector whose magnitude is changed by the factor lambda, but direction is the same. You have to remember this point. Direction remains same as that of A. Lambda A is equal to, if you take lambda A as it is positive, okay, then mode of A if lambda is greater than 0. For example, A is multiplied by 2, the resultant vector is 2A. For example. Okay, now what happens when any vector is multiplied with negative number? Okay, see, method is same. What happens? Multiplying a vector A by a negative number lambda gives a vector minus lambda A, whose direction becomes opposite, and magnitude is lambda times A. is lambda times A. So what is difference between positive number and negative number? When we multiply positive number, direction remains same, but when we multiply negative number, direction becomes opposite. See in figure. See in figure, we have one vector A which is multiplied by -2. Okay, for example, vector A is multiplied by -2. Then whenever you have multiply -2, okay, or minus negative number, its direction becomes opposite. Its direction becomes opposite. See, effect of vector A is in this direction, and effect of vector -2A is in this direction. Clear about this? Clear about this? Okay, so positive number, direction remains same. Negative number, direction becomes opposite. What about magnitude? So yes, as it is multiplied by -2, its magnitude will become twice. Its magnitude will become twice. Clear? Okay, it is easy topic, easy to understand. Okay, now lambda, I say lambda could be a scalar having its own physical dimension. It is not necessary that lambda is always number 2, 3, 1.5, 1.6, etc., etc., etc. It may be some quantity. It may be some quantity. For example, F is equal to ma. We know that acceleration is vector quantity. Force is also vector quantity, but this mass is scalar quantity. So we can say force is multiplication of vector with scalar. Force is multiplication of vector with scalar. And see, your answer is also vector. Your answer is also vector. So whenever you multiply any vector with scalar, your answer will be vector. Clear? One more thing. If you have this vector A, and you multiply this vector by -1, okay, then what happens if you multiply it by -1? Then yes, its direction becomes opposite. And magnitude remains same. Clear about this? Okay, so it is multiplication of vectors by real number, positive real number and negative real number. What is the conclusion? Yes, when you multiply with positive number, direction remains same. When you multiply with negative number, direction becomes opposite, and magnitude depends on that number. Clear? Pause your video and write down from bottom. Okay, see, we have discussed multiplication of vectors with real number. You may ask question, sir, multiplication of vector with vectors? Yes, that topic we will see in this chapter next. Okay, right now we will see addition of vectors by graphical method. Yes, you have two methods for vector addition, one graphical method and one analytical method. Okay, first of all we will see graphical method. Okay, see, graphical method you have to understand because we will use such method in 11th and 12th also. Okay, some laws, for example, gravitational law of Newton, okay, Coulomb's law, to use or to make some equations, to obtain some equations, we have to use such graphical method. Okay, so see here, addition of vectors by graphical method. Let us consider two vectors A and B. Here you are given two vectors A and B. Okay, yes. Length indicates magnitude, height indicates direction. What is first method? See what is first method. See here, first of all you have to take first vector. For example, it is vector A. So draw vector A with given direction and given magnitude. Okay, you have to draw vector A. It is vector A. Clear about this? It is vector A. Now see, it is tail of vector A and it is head of vector A. Clear about this? Clear about this? Draw first of all vector A. Okay. Now from head of vector A, draw vector B. From head of vector A, draw vector B. From head of vector A, draw vector B. See, here it is vector B. From here you have to draw this vector B. Means vector B, it is in this direction. Vector B, it is in this direction. Clear about this? Vector B, it is in this direction. So it is tail of vector B and it is head of vector. Clear about this? Clear about this? What you have to do? Remember again. First of all, draw first vector. First of all, draw first vector. That is vector A with its magnitude and direction. With its magnitude and direction. Then draw vector B. But from vector A. But from vector A. Okay. So see, as shown in figure, if you draw vector A, you have to draw vector B from head of A. Clear about this? Okay. So see, two vectors. What is relation between these two vectors? See, tail, head, tail, tail. Clear about this? Clear about this? What is resultant vector? Resultant vector is a vector from tail of first vector to head of last vector. To head of last vector. Clear about this? What is resultant vector? Resultant vector is from tail of first vector to head of last vector. It is called resultant vector R and it gives addition of two vectors A and B. It gives addition of two vectors A and B. Clear about this? So again, simple method. First, draw vector A, its tail, head. Draw another vector B from head of A. From head of A with its direction and magnitude. With its direction and magnitude. Yes. Then there is relation between these two vectors. Tail, head, tail, head. Okay. Tail, head, tail, head. Clear about this? Okay. So what is resultant vector? Resultant vector is a vector pointing from tail of first vector to head of last vector. Clear? So it is R is equal to A plus. Okay. Now as in this method, these two vectors A and B are added, and what is the relation between them? Tail, head, tail, head. So this method is called head to tail method. Head to tail method. Okay. Because you have to draw second vector. You have to draw second vector on head of first vector. On head of first vector. Clear about this? Yes. These two vectors A and B are added and the resultant is R and they are forming one triangle. So this method is also called triangle method. This method is also called triangle method. Clear about this? Clear about this? Okay. So it is called head to tail method or triangle method. Now the vector addition is commutative. What is meaning of vector addition is commutative? See, what is meaning of commutative? A plus B is equal to B plus A. It does not depend on order. A plus B or B plus A. Your answer will be same. How? For example, consider these two vectors. How to find A plus B? First of all, you have to draw vector A. First of all, you have to draw vector A. Yes or no? Yes, it is vector A. From this, it is vector A. It is its tail. It is its tail. Okay, now draw vector B from head of vector A. Okay, so it is vector B, it is vector B, tail, and it is tail. So what is resultant vector? Resultant vector is a vector from tail of first vector to head of last vector. It is resultant vector R. Clear about this? Okay, so it is R is equal to A plus B. It is resultant vector. Now, if I am taking B plus A, means I will draw B vector first. I will draw B vector first like this. If it is B vector, if I draw B vector first, okay. If I draw B vector first like this. If I draw B vector first. Clear about this? Clear about this? Now from this B vector, it is tail, it is head. Now you have to draw vector A, but vector A you have to draw from head of this vector. Head of this vector. Vector A, see, it is in this direction. So it is vector A. It is vector A. Clear about this? It is tail and it is head. Tail and head. So what is resultant vector? Resultant vector is vector from tail of first vector to head of last vector. So it is your resultant vector R. And this R is equal to it is B plus A. So see, from this figure you can say R resultant vector of A plus B, R resultant vector of B plus A. They both are in same direction and their magnitude is also same. Their magnitude is also same. Clear? So yes, the vector addition is commutative. Means if you find A plus B or you find B plus A, your answer will be same. Your answer will be same. Clear? How to find vector addition? With the help of triangle method. With the help of triangle method. Clear? Now we will see next method, which is known as parallelogram method. Okay, see, parallelogram method. Okay, in parallelogram method, what you have to do? Okay, parallelogram. In parallelogram method, what you have to do? See, parallelogram method is used for addition of two vectors. Okay, so if you are given two vectors, for example, you have two vectors A and B, and angle between them is theta. If you are given two vectors A and B, an angle between them is theta. So first of all, take this point as origin. Say it is x-axis. Draw vector A. Draw vector A. It is vector A. Clear? From this point O. From this point O. Now draw second vector B from the same point origin. From the same point origin. From the same point origin. With its direction. With its direction. Like this. With its direction. Clear about this? Okay, see, in triangle method, you have to draw second vector on head of first vector. In triangle method, you have to draw second vector on head of first vector. That's why it is called head to tail method. Okay, but in this method, you have to draw two vectors from the same common origin. From the common origin. From the common origin. Clear? Angle between them is theta. Angle between them is theta. Now assume these two vectors as adjacent sides of parallelogram and complete parallelogram. Draw lines, parallel lines. Okay, and complete parallelogram. And complete parallelogram. Clear? Clear? So it is point of intersection of these two lines. If you connect this common point from which two vectors are drawn, if you connect intersection with this common point, then this vector gives their vector addition. R is equal to A plus B. R is equal to it is A plus B. Clear about this? So parallelogram method, yes, it is easy method. What you have to do? You will be given angle between two vectors. Okay, first of all, draw vector A in direction of x-axis. Now what is angle between A and B? With the help of that, draw vector B in this direction. Okay, from a common point. Okay, take these two vectors as adjacent sides of parallelogram. Complete parallelogram. Okay, then diagonal passing from, yes, we can say it is diagonal passing from the common point. It gives vector addition. Clear about this? Okay, so you have to understand, yes, which method, when you have to use triangle method, law of parallelogram, they both are used for vector addition. Now if you know how to add vector, you can easily understand how to subtract them. Okay, it is addition of vectors. In next lecture, now we will see what is subtraction of vectors. Clear? Pause your video and write down from board.